All right, so on the first question, you were to figure out how your prediction, which was your first drawing, compared to what actually happened. Raise your hand if you can tell what you wrote on there in such a way that everybody else is gonna understand what you mean. Because remember, when you're thinking it in your mind, you might think it sounds like it makes sense, but other people might not think it makes sense. Abby?
So kind of like the yellow and the kind of black and brown at the bottom.
Okay.
And it was just kind of like that, but it turned to a little darker yellow and then a lighter brown.
Okay, good. So you've explained that very well. When I look at this right here, it looks like all of the hard stuff has settled by that point, right? All of the stuff that had mass and was hard settled by that point. And do you see any leaves and grass in that?
No.
Yes. It's submerged underwater. It's cloudy, but it is submerged under the water, right? Okay, anybody else have any thoughts that you can share about how that looks compared to what you predicted? All right, number 2 says compare and contrast your observation with what actually happened. I don't know how to do that so that that'll show on the screen. Okay, so compare means tell how they're the same, and you had to tell one way they're the same, and contrast means tell how they're different. So compare and contrast your observation with the Grand Canyon picture. So I'm looking at page 5 and comparing it to this. The bottom layers of the Grand Canyon are what compared to the upper layers?
They're like, the bottom layer is kind of like reddish and.
They're a darker color, aren't they? Do we see that same thing occurring here? Okay, so on number 2, I should have something, you might not have had it first, but I should have something about the darker colors settled toward the bottom on both the bottle and on the Grand Canyon picture, right? Anything else I can say? What's a difference between them? We're looking at the Grand Canyon picture and comparing it to this. What's a difference between them? Abby?
It's not really brown at the bottom, it's just like red and stuff. And then you got all the light, some of the light colors at the bottom too.
Okay, so the colors are different, aren't they? Why would the colors be different at the Grand Canyon than they are in here?
That's not rock.
Pardon me?
That's not rocks.
Well, that stuff at the Grand Canyon didn't start out as rocks, it started out as sediment, right? Just dirt. It got all mixed up.
They're not settlers.
It's not made of the same material, is it? Because I live where? West Virginia. And the Grand Canyon is where?
Utah, no,
Nevada.
Arizona.
Arizona, I think, isn't it?
I think part of it.
Oh wait, yeah, it's
Okay.
in like the borderline of Nevada and Arizona, I'm pretty sure.
Yeah, I'm pretty sure
Okay,
it's in
that
there.
makes sense. So that's not the same kind of ground as what we have out here, is it?
No.
And if I go to different places in the world, I'm going to see different kinds of ground again from those 2 places. It's different in different places of the world. Did anybody have anything else they could add for number 2 besides what we just discussed? We talked about colors, we talked about the different materials. The biggest difference I see is this stuff right here. What is this stuff right here? Water. And do I see that filling up the bowl of the Grand Canyon? Nope.
No.
I do see what looks to be a river at the bottom of it, but it's not going up the sides like this one is. So the water is a big difference. Okay, look at number 3. If I look at the Grand Canyon picture, which layers formed first and why?
I think like the clay.
The clay? It looks like it, because of red clay, I know if you go to other parts of the country, red clay is the color of its clay, and oh my goodness, it is so red it cannot come out of your clothes no matter what. We used to live in North Carolina in the Charlotte area, and my son played soccer, and that red clay would get in those outfits, and you couldn't get it out. It didn't matter how much you did to try to get that stain out, it wasn't coming out. So you can see the red clay settled at the base of the Grand Canyon, right? Now it says these layers would be considered the oldest. So when an evolutionist looks at this very same picture, they come up with the conclusion that the red clay is older than the sandy parts at the top. And they think that it formed in layers according to its age. Does this indicate that? No, because it's all the same age, and it's still settled that way. Right? The whole thing was shaken up at the same time. All of those dirts were put in there at the same time. The clay didn't have longer to settle than any other soil that we put in there. Therefore, that kind of puts a hole in their theory, doesn't it? The red clay isn't older, it's denser, and that's why it's sunk like that. Density has more mass. And when we felt the clays, we could tell that. Sorry, when we felt the dirts, we could tell that clay was denser than the other dirt, wasn't it? Yeah. Okay, look at number 4. Which layers formed last? These layers would be considered the youngest. When you look at the picture of the Grand Canyon, which layers formed last?
So the grass.
The box.
The sand.
Okay, it looks like grass and sandy type rocks. Have you ever picked up a rock that was a light brown in color and you rub it with your finger and it just kind of falls apart into like a sandy colored dirt?
Yeah.
Okay, that's what's at the top of the Grand Canyon. Can you see that? At the top of the Grand Canyon?
Yeah.
Especially if you look right around here, okay? Right around here, you can see it. That's that same kind of rock. If I were to pick one up, I could rub it with my thumb, and it's almost like it falls apart like a big clump of sand. But it doesn't look like sand when I first pick it up, but it falls apart like that. I think all of us have probably tried to rub a rock similar to that in our experience. And that's the type of rock that's found at the top of the Grand Canyon. Because that looser material, like sand, it is going to hold together from pressure, but it breaks apart very easily, doesn't it? If I were to stab it with a shovel or even rub a piece of it with my thumb, I can rub it apart and I see all those little bits of, looks like sand, coming off of that rock. And that's what forms at the top. So when I put number 4's answer down, those are the layers that formed last, because that's the top. So if the top formed last, these layers would be considered the youngest. So in that theory, sand is supposedly younger than other types of dirt, right? How long did it take the layers in this bottle to form? A day, 24 hours, right? How do your answers relate to the layers you see along the highway or in the layers of the canyon on page 5? Do we see similarity in how they formed? Yes, because here's what your answer is. The denser layers are on the bottom. Write that down. Number 6. Write it down.
What?
Jackson. The denser layers are on the bottom. What was the most dense dirt that we put in here?
The clay.
The clay. So in parentheses after that sentence, write the clay. The denser layers, God bless you, settle to the bottom. Some scientists believe the Earth's layers took millions of years to form. Using your Bible glasses, using what you know, what we've observed, what would you say? Now this is your answer for number 6, the second part. First part, team answer. Second part, your answer. Using your Bible glasses, what would you say to someone who said it took millions of layers for those millions of years for those canyon layers to form? What would you say? You think it's true? It took millions of years for those layers to form?
Yeah. Or
Did it take millions of years for our layers to form?
no.
How long did it take?
24.
24 hours. Does it make sense that it takes millions of years for those layers to form? If I can do a small one in a day, you think because of the size it would take millions of years?
Not like millions, but like you only took about like
Took about 1 year.
yeah, that's what
You know how I know?
the Bible.
Because the Bible tells me how long Noah's flood lasted. Because even after the 40 days of rain were done, it took over a year for the waters to completely recede.
Oh, yeah.
So for the waters to completely go back down to the earth and in the atmosphere the way they, to take all the flood waters down, took about a year. Okay? So think through. You need to be able to make a comparison so that if someone ever asks you how you could possibly believe that there's a God out there that created the earth, I have answers. I have scientific answers. Because a small scale demonstration shows us that all of those layers settled by density, not by time. Okay? When someone who believes in evolution looks at this picture on page 5, they're looking at all those layers and they're saying, well, that red clay layer is the oldest. And then over time, that lighter brownish red layer settled next. And then over time, that darker brown layer settled next. And then over time, that light brown layer settled next. Is that right?
No.
No, there was not any span of time in between for the varying layers. They settled according to density. And the denser dirt settled to the bottom because it's heavier. Right? That, to me, that makes sense. The heavier stuff comes to the bottom. If you have a glass of ice water, do your ice cubes float on top?
Yeah.
No. They might float up after they've been in there for a minute, but when you first put them in, they sink to the bottom, don't they? Because they're denser. But after the ice has begun to disperse a little bit, because it becomes water, they float back up to the top. Think about, okay, how many of you have ever tried to put sugar in a glass of iced tea that was unsweetened? What happens to the sugar granules?
It dissolves.
Pardon me?
It dissolves.
They do eventually dissolve. Have you ever gotten to the bottom of the glass and there's a bunch of sugar down there? Because it didn't dissolve all the way? That sugar sunk to the bottom. It didn't take millions of years for it to happen though, right? It happens because those denser things fall to the bottom. Yes?
Like how you put like flavor in the water.
Yes.
It doesn't all dissolve.
Yes. Some will and some does not. That is true. Okay, we're going to move on to page 10 in our textbook. 10 in your textbook, and we're talking about minerals in the earth. Now I want to keep my activity manual open because I'm going to be filling in on page 7 in this chart as we talk on page 10 through 15. You read it yesterday, or at least some of you got the chance to read all of it. I move rather quickly in here. Sometimes you may not get the chance to read everything before we get started talking about it. So what is a mineral? That's the first question on page 7. We're going to fill it in according to the definition on page 10. What is a mineral?
It's like a type of
Rocks are types of minerals, yes. Look on page 10 and tell me what the definition of mineral is. Go ahead. Yes.
A mineral is an inorganic substance found naturally in the earth.
Okay, copy that definition for number 1 on page 7 of your activity manual. An inorganic substance found naturally in the earth. The definition is right there in the second sentence on page 10 of your book. Yes.
I already read this page.
Oh, okay, that's okay. Just make sure you're right then when we answer the questions. So number 1, found closest to the holes in my activity manual book. So I've got holes just like I do in notebook paper. And the one closest to that is the definition found in the second sentence on page 10. Just write it down. Mason?
Get my water.
Not right now. Okay. All right. One of the words in that definition is inorganic. Now last week we learned the definition of organic. And organic material is when it used to be alive. So what do you think inorganic material is?
When it is alive?
Look at the next sentence. What does inorganic mean?
Can I say it?
Sophia?
An inorganic substance is made of things that have never been alive.
Okay. So listen to the difference. Organic means it used to be alive, like organs, or it's made of things that even are still alive. Organic at one time had life or has life. Inorganic, never any life in there. So when I look at my different dirts, would you say that's organic stuff or inorganic stuff? Pardon? No, dirt is organic. Clay is organic. All of those different dirts are organic. Now the sand may not be. It may have some organic material in it, but for the most part, it's busted up rocks. Just like that one that we talked about. I could hold it in my hand and rub, and it's like sand comes off of it. Okay? And so therefore rocks are generally inorganic. Made of stuff that's not been alive. Does that make sense? Okay. Look at number 2. What characteristics of minerals help scientists identify them? And if you read the rest of page 10 and then the subsequent pages, do you see that subheading characteristics of minerals on page 10 in the middle of the page? DJ, where's your science book then? We're open to page 10. I don't know how you wrote down that first definition without your book. Page 10. Quickly. You see the subheading, characteristics of minerals? All right, I'm going to keep looking for my next bold type headings to find the characteristics of minerals. Crystal structure. Does everybody see that first one? Write it down. Crystal structure on number 2. Crystal structure, number 2. That's the first one you write down. Crystal structure. Do you see any more on that page? No. Do you see any on page 11 of those subtitles? I don't either. Look on page 12.
Yeah.
What do you see?
Color and streak.
Okay, that's 2 different ones. Color and streak. Is there another one on page 12? I don't see another one on page 12, but I see one on page 13. Luster. There's my next one. Emma? I'm sorry? My pages are different. It's my page 15. Yes, color and streak are on page 12. Page 13 is luster. Thank you, Emma. All right, now look on page 14. And what's the next one?
Next one is
Hardness. And then there's one more on page 15. Cleavage and fracture. You know what it is when you fracture a bone? What does it mean?
break.
It breaks. So what do you think fracture is when I'm talking about rocks?
Break.
How easily they break. And cleavage indicates a certain type of break. Like if it's, it can be there, you can have a jagged break, or you can have a break where it comes off like a sheet almost. Okay? A clean break is what a doctor would call that. It's a clean break. Okay. Now go back again to page 10, and we're going to complete the chart so that we can determine what each of these characteristics tell the scientists. So if I look at the first one, crystal structure, look at the definition of a crystal. See where I am on page 10?
Yep.
The definition of crystal says a crystal results from the orderly arrangement of the particles that make up the mineral. So what am I going to write on that first blank under crystal structure?
Results from this.
Emma? Yes, orderly arrangement. Write that down. Orderly arrangement. Let's see if I can see where the next one is. Okay, look at the next paragraph. Most mineral crystals have straight sides and sharp corners or edges. blank. They can be blank sides.
Short. Straight.
Straight sides. Good. So straight goes in my next blank. And then if I finish that thought, however, some crystals, such as the desert rose, that is pictured there on page 10, form in rounded shapes that resemble a flower. All right, look at the very next sentence. The sizes of crystals vary. So size, what goes on that blank?
Size.
Varies. Good, I heard somebody say it, varies. What does that mean if it varies? Emma? Jackson?
Changes.
It won't, yeah, it does change because they grow. It means that they're different. It can be different. You can have little crystals, you can have big giant crystals, you can have crystals in between. Abby?
You say the answer after, like, you say it with the sentence, the answer.
Varies, yeah, size varies. So varies is what you put in a blank. Is that what you mean?
Yeah.
Okay. All right, now let's turn the page and look at color. All right. A mineral may be identified by its color. The color of a mineral is the color that you see. The amounts and variety of elements in a mineral can cause a wide range of colors. There's where I'm going to find my next answer. Can be blank colors.
Can be different.
Different colors, many colors, either one of those would work. We're on the second block, color.
What can we throw on it again?
Many. Let's go with this one. All right, because the colors can be similar, look at the second paragraph. Some minerals look similar and are hard to tell apart. For example, gold and pyrite are about the same color. How many of you have ever seen fool's gold? The mineral called fool's gold. Well, the literal name or the scientific name of fool's gold is pyrite. Well, it's hard to tell the difference, isn't it? In fact, they look so much alike that pyrite is called fool's gold. Mineralogists may use streak tests to tell them apart. The streak is the color of the mark that is made when a sample is rubbed on a harder surface. So blank are used because colors can be similar. What goes in that blank? What did I just say? The end of the second paragraph. Read it for yourself. The end of the second paragraph on page 12. Streak tests. Streak tests goes in the blank. All right, the next one. Blank is the color of the mark made when a sample is rubbed on a harder surface. What word goes in there? Jackson? Streak. Good. Streak goes in there. So from that list on page Activity Manual 7, number 2, we've done crystal structure and color and streak, right? Tomorrow we'll start what one? Luster. Very good. All right, I will have some adjustments to make on the science because we're not quite as far along as I'd want to be today. So there will be a little bit of adjustment made on what is going to happen in science in the next few days. So if your parents are the type that look ahead, keep in mind that they're going to have to adjust a little bit with us when we adjust. Now I need everybody to turn in their their activity manuals, because I'm going to check layers of the earth today. You've had plenty of time to do this page from last Friday. So layers of the earth, crossword, should be finished. It goes over there. your language books and your science activity manuals after school today, as well as your Bible. Now, in your